Howdy, guys. Here we go with 9.2, factor by grouping. So remember from 9.1, you guys already learned how to start the factoring process, and that is by finding a GCF, a greatest common factor. Make sure you're always picking out the greatest common factor and not just a common factor. So if I look at all of my terms here, you might first notice that you could take a 2 out. So let me do that. Well, if I take the 2 out, then I'm left with 6x to the third plus 2x squared plus 3x plus 2, because really all I'm doing is just dividing each of these terms by 2. Okay. If you look inside your parentheses in your leftovers, you want to make sure that there's nothing else that they have in common. So can they all be divided by the same number? No. I don't see any number they could be divided by, and they don't all have an x. This one doesn't have an x, so I can't pull that out. So it looks like this is factored by GCF, and the correct GCF was 2. You could check it, remember, you could just multiply it all out, and you would want to make sure you came out with the original problem. Okay? What we are going to learn now, and in the rest of the chapter, is after you take out a GCF, or if there isn't a GCF, other ways to factor. And the way we're going to learn today is called factor by grouping, and you use it when you have 4 or more terms. Okay, so if you look back at that example, there were 4 terms here. So that would be a good case to use factor by grouping. We won't do that one though, we'll start with a new one. So we see that this problem has 4 terms. To factor by grouping, what you want to do is split it in half. So you want 2 terms in the front and 2 terms in the back. So I'm just going to draw a little line here to show I'm splitting it. So for a second, I just want to think of these as 2 separate problems. So I'm only going to be looking at this part. And then factor it just like you learned before. What's the GCF here? Between 4x and 8y, the GCF is 4. If you take that out, 4x divided by 4 would just be an x, plus 8y divided by 4 would be 2y. Now for a second, let's just look at the back half. Oops. What's the GCF in the back half? It's an a. So if you take an a out, x would be left here, and 2y would be left there. Okay, now let's put that all together. So I have this and I have this. But right now they really do look like 2 separate problems, and I need to connect them. Is this a positive a or a negative a? It's a positive a, so I'm just going to stick a plus sign in. So now this does look like one long problem instead of 2 completely separate things. So after I split it in half and I factored each half, I'm left with this. Let's take a look at this. Do you notice anything that's kind of nice about this maybe? Look at your parentheses. They're the same. So what you can do is you can factor out those parentheses. So I'm looking at, actually what I have here are 2 terms. Terms are separated by multiplication. This is 4 times this whole piece. This is a times that whole piece. So I actually have 2 terms. Both terms have x plus 2y. So I can factor out that x plus 2y. If I take that out, in the first term, all that I would be left with is a 4. And if I take it out of the second term, all that I would be left with is an a. So it turns out that this factors in to x plus 2y times 4 plus a. Keep in mind, that is your answer, but you can check your answer. So let me just move this off to the side and do a quick check. So this is just my check over here. The way you would check it is just by multiplying everything out. Keep in mind how you do this. You're just going to do a bunch of distributing. So x gets multiplied by 4, which is 4x. X gets multiplied by a, so plus ax. 2y gets multiplied by 4, so plus 8y. And 2y gets multiplied by a, so that's 2ay. Compare what we got here to our problem. It's in a different order, but it's all there. There's 4x, there's ax, there's 8y, and there's 2ay. So these are equivalent, so our check works out. Okay? So let's try another one. When you're factoring, you still want to start by looking for a GCF. Every factoring problem, that should be your very first step. Do you have a GCF in this problem? I don't see one. I can't say B because this doesn't have a B, and I can't have any number because this doesn't even have a coefficient. So there's no GCF. But I can count that there are 4 terms, and I know when there are 4 terms, I can try factor by grouping. Repeating the steps for factor by grouping, you're going to split it in half, and you're going to factor each half separately. So what's the GCF in just the first half? B squared. B to the third divided by B squared, remember you're really subtracting the exponents, that's B to the first. Minus 3, and the B squared came out, so that is gone. The GCF in the back 2 terms, the back half, is a positive 4. Well, if you take a 4 out of 4b, all that's left is b. And if you take a 4 out of negative 12, remember you're dividing, so that would be negative 3. Okay? Now again, remember you have 2 terms here, and those 2 terms have a common factor. The common factor there is b minus 3. If you take b minus 3 out completely, then you are left with b squared plus 4. That is your solution. That's your factored answer. Now, usually when I teach this, students at some point will say, why don't I have to write b minus 3 there twice? Well, I showed you that the checking does work the way we have it written, with that term only coming out once. But a different explanation, let's say, let's let b minus 3, and I don't want this to confuse you, so if what I do here doesn't make sense to you, it's okay. But if you're curious why you're not writing b minus 3 twice, hopefully this will answer that. Let's let b minus 3 equal x. Well, then this line right here would be b squared times x, because b minus 3 is x, plus 4 times x, because b minus 3 is x. So if I were asked to factor this problem, and don't let that dot confuse you, you don't have to have it there. If I were to ask to factor this problem, I would see that these both have x's, so my GCF would be an x. I'm pulling that GCF out. Even though it's in both, I'm only writing it once. That's how you factor with the GCF. It comes out once, it gets divided out of everything. And I'd be left with that. And of course, you could check it by distributing it back through, and you'd see that that's what it is. Okay, but remember, x wasn't really x, it was b minus 3. So if I substitute that b minus 3 back in for the x, I can see that that is what I really got. Okay, so it only gets written once because it's the opposite of distributive property. And when you do distributive property, you don't have to write that thing out front more than once. We know it's going to everything. Okay, try another one here. Remember, any factoring problem, you always start with a GCF. Write that on your paper somewhere. For any factoring problem, always start by looking for a GCF. Always, always, always. Super important that that is where you begin. Okay, so do we have a GCF in this problem? Not in all of the terms we don't. They don't have a number in common. They don't all have an A. They don't all have an X. They don't all have a B. They don't all have a Y. So I count how many terms. If there's 4 terms, which there are, I can factor by grouping. GCF in the first half is, I was going to say 4, but 14 is not divisible by 4. So it's just a 2. Any variables? Sure, they both have an A. So that leaves me with 2x plus 7y. And in the second half, hopefully you guys are seeing that there's a GCF of 5 and a B. Okay. If you put plus 5b, which remember, you absolutely have to have a sign right here. that connects it to the first half. If you put plus 5b there, you are left with negative 2x and negative 7y. And if you look here, now your parentheses don't match. If your parentheses don't match, they're not a common factor. You could not factor it out. So you have to make sure that these parentheses are matching. If they're not matching, it's possible you factored wrong, you didn't get the greatest common factor, or if it's one like this where just your signs are wrong, then you need to change the sign here. So instead of pulling out a positive 5, let's pull out a negative 5. So if I make this a minus 5b, negative 10bx is now positive because I pulled the negative out. And then negative 35by divided by negative 5b is positive 7y. Now both of my sets of parentheses, those are matching. So I can factor them out, 2x plus 7y, and what is left is 2a minus 5b after the 2x and the 7y came out. This one has no numbers at all variables. Still start by looking for a GCF. Is there a GCF in all the terms? There is not. How many terms are there? 1, 2, 3, 4. Remember, terms are separated by plus and minuses. So, because there's 4, you can split it in half. The GCF in the first half, there isn't one. Is there one in the back? There is not. So before you get ahead of yourself and just say that this is prime, you've got to think, can I reorder these? And the answer is yes. So if I leave AY first, could I take one of these other terms and move it next to that, and it would have a GCF? Sure, you can take this negative AB and bring it out front. And then put your plus CB, and then your minus CY. And keep in mind you can do this, because if I did this with numbers, say I had 4 minus 6 plus 3, that'd be the same as 4 plus 3 minus 6. Because 4 minus 6 is negative 2, plus 3 is positive 1. 4 plus 3 is 7, minus 6 is 1. So as long as you keep the sign with the number, you can rearrange that. So if you don't see any GCF in the first half, see if you could rearrange it and make the first half look different. Now I do have a common factor of A. Taking that out, I'd be left with the Y and the minus B. And then back here, I see that I have a common factor of C. And then I'm left with B and minus Y. Now remember, your parentheses have to match. Do these parentheses match? Well, I can see that they're in the wrong order, so let's reorder that. Again, as long as you keep the sign with things, you're fine. So this Y remains negative, this B stays positive. Do they match now? They're in the right order, but each sign is wrong. Positive Y, negative Y. Negative B, positive B. And how do we fix that? Well, we said in the last problem, change what sign you took out. So I'm going to leave the front half alone, but instead of taking out a positive C, I'm going to take out a negative. Hold on. I'm going to take out a negative C. So if I take a negative out, this Y now becomes positive, and this B has to become negative. Okay, so if I take a negative out of a negative gets left over because two negatives make a positive. Now my parentheses do match, so I factor those out. Y minus B comes out, and then A minus C is what is left. Again, remember, you can always multiply these back out. We had to do some weird changing here, so you might not be sure you're right. Multiply it back out, make sure you got what you started with. Okay, this one looks a little different. Take a look at it. Hopefully you are recognizing this is almost like halfway done. They've already done the first part of splitting it in half and finding the GCF. Then we had parentheses that matched. So all you have to do is the last step. Factor out the A minus 2B, and what's left is 3M minus 5N. A lot of times students want to distribute this and like start over, but they've already done half the work for you. Don't go backwards and then have to do that same work again. Just finish the problem. Okay, take a look at this one. What's the very first thing you're supposed to do for any factoring problem? Find the GCF, right? I see a GCF on this one. Maybe. Check it out. You guys see if you can find any GCF. Coming up with anything? Okay, maybe not. I don't see one. So if there's no GCF, split it up. 4 terms, split it in half. The GCF in the first half is 5x. And remember, if you don't see that right away, if you're taking longer than I am, that is okay. When you do your work, that's fine if you take another minute to get that. Then we're left with 6y plus 75 divided by the 5 would be 15. And of course, the x came out, so we're done with that. In the back half, a GCF, you might have to do some dividing, think about what you can divide 42 by, see if any of those numbers work with 105. So maybe your first thought is, well, 42 I know is divisible by 6. Is 105 divisible by 6? Turns out it's not. Well, I also know 42 is divisible by 7. Is 105 divisible by 7? It is. So let's try pulling out a 7. See how these are both negatives though, and these are both positives? That means what we get in our parentheses, we're going to want to be positives. So to do that, we'll have to pull out a negative 7. So that leaves us with 6y plus 15. And our parentheses here, they do match. So I can factor that out. And then I could have 5x minus 7 left over. Anybody see anything wrong with that? Remember from section 9.1, I said whatever you have in your parentheses, they cannot have any common factors. Turns out there is a common factor, not between 5 and 7, but between 6 and 15. There's a common factor of 3 there. They can both be divided by 3. So I've got to pull that GCF out of 3. That leaves me with 2y and plus 5. Okay, so this is your final answer. If you wrote this as your answer, that would not be correct because it is not completely factored because there was a GCF. So what that means is actually from the very beginning of the problem, we could have pulled out a 3. So we said we couldn't find a GCF, and maybe you saw it, but I was pretending I didn't. The GCF between all of those terms is actually a 3. So if we had we done that from the beginning, let me show you what your problem would have looked like. You would have taken a 3 out of everything. Then you'd be left with 10xy plus 75 divided by 3 is 25. 42, negative 42 divided by 3 is negative 14. And negative 105 divided by 3 is minus 35. What I suggest then is you take this 3 and you write it all the way down into an answer. Okay, so wherever I think my answer is going to end up, write it there. That way you're not going to forget it, because what a lot of students will do is then you'll have to keep factoring this part, but they'll forget to put the 3 in the answer. So drag that 3 all the way down, whoops, wherever you think it's going to end up. I'm going to move this and write it down there so that you don't forget about it. Then just focus on the stuff, the leftovers, and continue to factor that. So there are 4 terms, so I'm going to do grouping. Now looking at it this way, my GCF is 5x. That leaves me 2y plus 5. And then in the back, it'd be a negative 7, which leaves me 2y plus 5. So there's my 3. Along with my 3, I have a common factor of 2y plus 5. And then I have 5x minus 7, which is in fact what we got doing it the other way. So either of these ways is fine, but the easier way is to find the GCF at the beginning, because then you're going to always work with smaller numbers, and most students aren't going to remember to pull it out at the end. So try to start every single factoring problem by finding that GCF. All right, I've got two that I want you guys to try. So pause the video and try these two problems. Okay, you may have gotten stuck right here. You might have gotten that far and gotten stuck because you're looking at this and you're saying there's no GCF there. If there's no GCF, you're just going to put a +1 because you can pull a 1 out of anything, right? And you'd still be left with 2x minus 3. But that works out because what's in your parentheses is a 2x minus 3. So that can be factored out and you're left with x squared plus 1. So if there's no GCF, you're just going to put a +1 and then see if your parentheses match. If they don't, then you might need to rearrange things, or it could even be prime. But a lot of times it'll work out this way. Did you remember to look for the GCF at the beginning? Hopefully you did. If you didn't, make sure you pulled it out at the end. This has to be your final answer, nothing else. There has to be that 2 GCF out front. All right, one more problem. Oops, there it is. A closed cardboard box has a volume of 60x to the third plus 34x squared plus 4x. What expressions can represent the dimensions of the prism? Well, a cardboard box is a prism, right? So we want to know the dimensions of this, which means we want to know the length, the width, and the height. So we're trying to find three things: a length, a width, width is probably this way, and then a height, that all three of those multiplied together are going to give you this. Well, all that is just factoring this out. Okay, so we know that volume is this whole thing. We need to find the three individual things that multiply together to get that. They're not going to be exact numbers. They're still going to be expressions with an x. So how do we factor? Oh, you know what? There's a typo here. Hold on one sec. Okay, so change that. Look at these. Look at what these are. It should be right on your packet, but ignore what I first had up there. Okay, so if you're looking at 60x to the third plus 34x squared plus 60x plus 34, we're just going to factor this. The very first thing you're supposed to look for when you're factoring is, of course, a GCF. Do you see one? 2. 2 looks to me like it's the greatest common factor. So then we have 30x to the third. 34 divided by 2 is 17. And then those same coefficients again. Okay. Now, can I factor further? Well, I hope so, because remember, volume equals length times width times height. And right now, all I have are 2 factors. 2, and then this whole thing. I need 3 factors. So ideally, we will be able to factor this big polynomial further. Well, pull 2 down into your answer. That's one of your dimensions. And then in the leftover stuff, can you factor that? There's 4 terms. Split it in half. GCF in the first half. Well, 17 is prime, so it's only divisible by 1 and 17. 30 is not divisible by 17. 1's not going to help. So we'll say that x squared is our GCF. 30x plus 17. In the back half, 30x and 17, there's no GCF, so all I can write, and I have to write a +1. Then I have 30x plus 17. Remember that every line that you're writing should always multiply back out to the line before it. So that's why I have to write the +1 so that I can multiply back out and get this stuff. Then these have a common factor in those parentheses, 30x plus 17. And when I take that out, what I'm left with is x squared plus 1. So my final answer is this, which means these are my possible dimensions. Volume equals length times your width times your height. And of course, those could all be mixed together, but there's the 3 dimensions that are possible for this closed cardboard box with that volume. Okay, keep on keeping on.